Welcome to the class student. So this is the last chapter of your 12th class syllabus, second semester in chemistry, that is biomolecules. And in biomolecules you have to study about carbohydrate and proteins and nucleic acid. The syllabus has been reduced much, so only limited portion is there. So first I will take carbohydrate. This all biomolecule I will be finishing through it, only videos already recorded, and while nitrogen containing compounds you will be studying through online classes through Zoom. Okay, so here first I will teach you about the carbohydrate. Carbohydrate is, as you know, is organic compound containing carbon, hydrogen and oxygen also. So there are many other compounds you have studied which have carbon, hydrogen and oxygen too, like alcohol, carboxylic acid, aldehydes and ketones. But carbohydrates are little different from them in the way that they are having poly structure, long chain structure, and they are having hydroxyl group, alcoholic group, aldehydic group, ketonic group also in them. Maybe both, maybe all three, or maybe any two of them, or maybe just one. So it depends upon. So carbohydrate, that definition, if you see, this is the common definition. Polyhydroxy. Poly means many, hydroxy means OH group. Polyhydroxy. Aldehydes, CHO, or ketones, CO. Aldehydic group is CHO and ketonic group is CO, which you can also write as like this. And this is ketonic group, and this is your aldehydic group. So they have any one of these two as well as OH group. Any one of these two along with this OH group. So polyhydroxy means more than one OH group and at least one aldehydic group. Then it is carbohydrate, or many hydroxyl group 2, 3, 4, and also your ketonic group. Then also it is carbohydrate. Then if they are not polyhydroxy aldehydes, they are polyhydroxy but not aldehydes. Only hydroxyl group is there, many. Polyhydroxy only without aldehyde or without ketones means they are large polymeric molecules. Large polymeric molecules. And these large polymeric molecules which have no aldehydic group, no ketonic group, but they have hydroxyl group, when they undergo hydrolysis, hydrolysis means reaction with water. So when they undergo hydrolysis, they produce what? Polyhydroxy aldehydes and ketones. So themselves they do not have aldehydic and ketonic group but they have many hydroxyl group, and then on hydrolysis, on reaction with water, if they are turning into with hydroxyl group, aldehyde, hydroxyl group and ketone, then they are carbohydrate. So basically you can understand that carbohydrates are nothing but polyhydroxy, aldehydes or ketones. Hope it is clear to you. Then classification. There are different modes of classification. Three modes are basically used. First is behavior on hydrolysis. When they are hydrolyzed, when they react with water, what is their behavior? Behavior means what is the end product form. Then second, your mode of classification is taste. whether they are sweet in taste and are not sweet in taste. So third is your reducing behavior, whether they can reduce certain reagent like tolerance reagent and your failing solution. Tolerance reagent and failing solution I will come later on. So first I go to this behavior on hydrolysis. The behavior on hydrolysis, on this basis that carbohydrates which are being hydrolyzed, okay, when they react with water, and then they are producing different kinds of carbohydrate. So in them, one of them is called monosaccharide. So they are mono, di and oligosaccharide. But disaccharide, oligosaccharide is now removed from the syllabus. Only monosaccharides you have. So you can say that carbohydrates on hydrolysis are classified as monosaccharides for your syllabus now. And these are those polyhydroxyaldehyde or ketones, any one of the two, either aldehyde group or ketonic group, which cannot be decomposed further by hydrolysis to give simpler carbohydrate. For example, I hope you have studied the reaction sucrose. Sucrose is your C12H22O11. Okay, this is sucrose, and this sucrose you have studied sugar, ordinary sugar, and when this reacts with water, hydrolysis, it produces C6H12O6 plus C6H12O6. One is glucose and the other is fructose. This reaction you must have studied in all classes. So here this is a carbohydrate which on hydrolysis is producing further smaller group carbohydrate, simpler. So this is not monosaccharide. This is producing two your smaller saccharide, so therefore it is disaccharide, not in syllabus. This is your monosaccharide because now they cannot be further hydrolyzed to a simpler carbohydrate. So glucose and fructose, glucose and fructose and galactose also, they all are monosaccharide and having same molecular formula. I am saying molecular formula, not the structural formula. Molecular formula is same for all these three, but the structural formula is different, but not in your course to study in detail. So I will not stress upon that. So the general formula can be written for these monosaccharide also like this CH2O whole N. CH2O whole N means what? N is your, can be either 3 or 4 or 5 or 6 or maximum 7. Okay, so N can be from 3 to 7, remember. So if this is the basic formula, CH2O whole 3 or whole 4 or whole 5 or whole 6 or whole 7, then they are monosaccharides. So this much you need to know for monosaccharide only, and we come to the third your classification, reducing behavior, quite important and as a test. So two kinds, one will be reducing, the other will be non-reducing. Reducing sugars are those sugars means which are sweet in taste mostly. Then reducing sugars, here I will say monosaccharide. Monosaccharides are reducing sugars if they are reducing tolerance reagent. Tolerance reagent you have practiced in the lab, you have done experiment. If you remember, you tested formaldehyde with tolerance reagent. When you heated with tolerance reagent, you obtained sulfonylurea. I hope you remember. And glycerol also you have tested with tolerance reagent. When glycerol was heated with tolerance reagent, you saw silver mirror. So it means that the glycerol has reduced tolerance reagent and formaldehyde is also reduced tolerance reagent. Okay, but it does not mean that they are carbohydrate. Okay, it means that they are reducing agent. If you remember, I had told while I was giving you experiment practice that a tolerance reagent, when you get from tolerance reagent silver mirror, it indicates the compound which you have, glycerol or formaldehyde, they are reducing agent. In case of formaldehyde, you saw as soon as you added formaldehyde, even without heating, you obtain silver mirror. On the other hand, when you added glycerol, then on heating with tolerance agent, you obtain silver mirror. What is the difference? One gave quickly, glycerol did not give quickly, formaldehyde gave quickly. The one which gave quickly means is a stronger reducing agent. So here I am emphasizing upon the reducing agent. So any chemical organic compound, if it is on being heated with tolerance reagent, produces silver mirror, then it is reducing agent. So here sugars which produce silver mirror with tolerance reagent, they are reducing tolerance reagent. And also Fehling solution. Fehling solution, blue color solution was given even in your practical examination also, it was given to you. So Fehling solution, when you heat organic compound with Fehling solution, what will you see? A red color precipitate will be deposited at the bottom. So glycerol could not give this test, but formaldehyde gave, because formaldehyde is a stronger reducing agent. So here monosaccharides which are able to reduce tolerance reagent to silver mirror and which are able to reduce Fehling solution to red color precipitate, they are considered as reducing sugar. What are the example? All monosaccharides. It means glucose, fructose, galactose. All these three are reducing sugar. And also all disaccharides except sucrose. This is your sucrose, ordinary sugar which you eat. That this sucrose, the C12H2211, this will not reduce tolerance reagent and also your Fehling solution. But maltose, maltose is the sugar obtained from maize, bhutta or what you call. From that sugar which is obtained, carbohydrate obtained, that is maltose. So maltose is also having the same structural formula, general formula, and it is your reducing tolerance reagent in Fehling solution, while sucrose is not. Understood? This is what it means. So reducing and non-reducing. So there are some monosaccharides can be which is non-reducing but not in your syllabus. Okay, exceptional cases are there but not mentioned. So remember reducing, non-reducing. So this sucrose will be the example of non-reducing so far. So this is here. Now I will be teaching you next the D and L configuration, capital D and capital L configuration. Here D does not stand for dextro, L does not stand for levo, which you have seen is optical isomerism. It has nothing to do with dextro and levo. First of all, this you keep in mind. DL configuration. Configuration means a special arrangement of different parts to specify the structure. So here different part means here different groups in this molecule. So D and L configuration, how can you decide whether it is deconfigurated monosaccharide or L-configurated monosaccharide? So for that you have to look for asymmetric carbon. Asymmetric carbon is a chiral carbon. Asymmetric means a carbon which has all its four valencies satisfied by four different atoms or group of atoms. So here if you see that this carbon, if you take, this is also chiral. 1, 2, 3, 4, all this is having different, this is different, this is different, this all is different. So this is also chiral. But not all chiral carbon atom will help you to identify whether it is D form or L form, deconfigurated or L configurated. So you have to look for first CH2OH group as far as it is concerned to monosaccharide. So you have to look for CH2OH group wherever you have. And then to this CH2OH group, if you see that, which is the chiral carbon. So here chiral carbon is this. You can make a asterisk on it. So all four valency of this carbons are different. So CH2OH group, this is here. To the right side of this H1 OH group is present on chiral carbon. So next to CH2OH group, if you see OH present on the right hand side, then it is deconjugated. So here also you see this is CH2OH, but there is no OH here, so you will ignore that one. And this is not chiral also. So you will consider this CH2OH, and this is chiral. And here again it is on the right hand side, so it is deconjugated. So here you have aldehyde group, here you have ketonic group, but the general formula is same, C6H12O6 for both. So this is glucose with aldehyde group, this is fructose with ketonic group, and here you can see that both of them are deconjugated because OH is present at the chiral carbon next to CH2OH, or you can say OH group is present at right hand side of CH2OH group on chiral carbon. And here also OH group is present to the right hand side of CH2OH group at chiral carbon. So this is D form configuration and L form, and this is on the left side. OH group is on the left side, then it is L. So if you have to write L form, then L will be OH this side, H this side. So this will be L. So if you, this plus sign is indicating it is dextro or levo. You have studied D is for dextro and plus sign is also for dextro. So this plus sign is indicating that this is dextrorotatory, deconjugated dextrorotatory, and here L conjugated dextrorotatory. If you take this H here, OH here, it is D form dextrorotatory. Okay, if it is minus sign here, D minus glucose, if it is so, it is levorotatory. So here you have not to stress upon this thing, your dextro and levo, but you have to see whether it is deconjugated or it is L conjugated. So this is all about your D and L configuration, and now I'll teach you the properties of carbohydrate monosaccharide. So chemical properties of glucose. This is also the formula of glucose. Instead of writing the expanded form CHOH 4 times and CH2OH, or OH this side, H this side, and opposite and all. So this is the condensed form of writing the formula of glucose. It is aldehyde group, so it is glucose. So when it is treated with hydroiodic acid without red phosphorus and heating, if simply you add a HI, product will be this N-hexane. This will be CHO. This will be reduced. CHO group will be reduced to alcoholic group. There it is primary alcohol. This will reduce to primary alcohol and further reduce to an alkyl group. You must have studied that aldehydes are reduced to alkyl groups. So here that is taking place. But when we take red phosphorus and when we take red phosphorus and heat with HI, the reaction becomes very fast, vigorous. And so that is the advantage of taking red phosphorus and heating. Now next is with hydroxylamine. So again glucose here combining with hydroxylamine. Hydroxylamine formula you know is NH2OH, which I have told if you remember. In the previous classes of organic which I gave, you should write like this, HNHOH. So one H you write separate. So this is your hydroxylamine. Hydroxylamine reaction will be easier for you to do, and the bond will break from here. Here negative and here positive. In aldehyde in details I have taught this. So this will undergo electromeric effect. Pi bond will be broken. Pair of electron will be free, will be transferred to the oxygen, which is more electronegative than carbon. So this will come to a new electronic condition. What it will be? One carbon. Then we have CH, whole 4 as it is, and CH2, OH as it is. And here this H will remain, and here this is double bond will turn to single. Here is negative charge, here is positive. So to the negative, this positive will be attached, and to this positive, this will be negative, this is positive. So to this positive, this negative piece through nitrogen. So here will be attached NH-OH. This piece will be attached here. You know that on this carbon, so much big grooves, steric hindrance is caused. Steric hindrance means crowding. And because of the crowding, they will be repelling, the bulkier group will be repelling each other, and so they will try to become stable, and so they will be releasing themselves one molecule of water. So that is, if you remember, then from here one OH from here and H from here, that will be out as water. This reaction you have done earlier in aldehyde chapter, if you revise. Then we will have carbon left, H left, this OH is gone, this is here, this H is out, so we have N, O, N, H, and this H is gone. So to balance the valency, there will be a double bond, and this group will remain as it is, CH-OH, whole 4, and this will remain as it is, CH2OH. So the product of hydroxylamine, when hydroxylamine combined, the product is called oxime. Always, if you have learned aldehyde thoroughly, then you will say oxime. So this is glucose, so glucoxime. Starting from glucose, glucoxime. If you start from aldehyde, aldoxime. If you start from ketone, ketoxime. Starting from glucose, so glucoxime. Main is your oxime. The product formed is oxime. Water is released. Now next reaction is with bromine water. Bromine water is a mild oxidizing agent, weak oxidizing agent, and it is only able to oxidize aldehydic group to carboxylic group. Aldehydic group is a strong reducing agent. Since it is a strong reducing agent, so it can be oxidized very easily. So only when bromine water is mixed with glucose, this is glucose, then bromine water is releasing oxygen. Reaction if you write, then hydrobromic acid will be formed, HBRO, like HClO, hypochlorous acid, you have studied in 10th. When this decomposes, it gives HCl and nascent oxygen. So this will decompose, what it will give? HBr and nascent oxygen. So nascent oxygen is set free by bromine water, and this nascent oxygen is an oxidizing aldehydic group. So CHO group is turned into COH group. Rest part is remaining same. This is glucose, so this is gluconic acid. This is D-glucose, so this is D-gluconic acid. Okay, so two things you have to remember. Bromine water is a mild oxidizing agent, and because of this mild oxidizing nature, only aldehydic group is turned into carboxylic group. Okay, and bromine water, Br2 over water, when you see on the arrow in a reaction, it means bromine water is used. Now with conc HNO3, concentrated HNO3, Concentrated HNO3 is a strong oxidizing agent. This is mild, weak, and conc HNO3 is a strong. Since it is a strong, therefore two things happen. That is, not only your aldehyde group is turning into carboxylic group, but your primary alcoholic OH group is also primary alcohol, I should write. CH2OH, the CH2OH is primary alcoholic group. This is turning into carboxylic. So two things is happening. CHO group is turning into this, CH2OH group is also turning. So you can see CHO, this is turning into COH, and CH2OH is also turning into COH. So both of these groups are turning into COOH group, because conc HNO3 is a strong oxidizing agent. So this is turned, one oxygen is added, and here this is turned, one oxygen is added. So two hydrogen atoms which are free and one more oxygen that will release water. So this is called saccharic acid, dicarboxylic acid also you can say, dicarboxylic acid. And this is your D, not dextro but D. It could be dextro also, but plus and minus we have not emphasized upon in this chapter. So deconjugated saccharic acid. So important thing, comparison, mild oxidizing agent, only CHO group is turned into this. A strong oxidizing agent, both terminals, CHO and CH2OH groups are turned into COOH group. Now next property. Now fifth properties with acetic anhydride. I will teach you in general way. Alpha and beta type of glucose is not in your course, but in the book it is given that way. But I am teaching you through the deconjugated dextro or deconjugated glucose through that structure. So you have a C double bond OH aldehyde group. 4 you have secondary alcoholic group, and 1 you have primary alcoholic group. This is your deconjugated glucose. Okay. Then this combines with acetic anhydride. This is acetic anhydride. Acetic anhydride is obtained when acetic acid is dehydrated. From 2 molecules of acetic acid, 1 molecule of water is removed, then we get acetic anhydride. So in mechanism, in class 11th you have done, and here also in organic compound chapter, you have seen that this breaks from here, negative and positive, either from here or from here. If it breaks from here, this is negative, then this will be positive. Since I have broken from here, this is negative, this is positive. Now this will be attacking OH group, OH bond. So one OH bond reaction I showed to you. Here, this OH bond is there. So this I write this way also, then I hope it will be more clear to you. CH OH COHH 4, 5 and 6 CH2OH OHH, and this is OH, and this is OH, and this is H. This is deconjugated. Same this thing is here, structural form. So this bond this bond will be affected. This bond will be broken. OH, and if I write here 1H here, 1H here, and O and H, the structural form, then this bond will break. OH, 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 this only, and this. Not here. O and H here. Bond between oxygen and hydrogen will be broken. So when this bond will be broken, here will be the negative charge, here is the positive. To the negative part, this positive piece will attach everywhere. Here negative, here positive, everywhere. And the positive of this will be attaching to the negative. So that's what I am going to do. So here it is there, then I write what you will have. HC double bond O. This will remain as it is. This is O, and here to this negative I'll attach positive. OCH3. Okay, and this H will be attached to the negative. So we will have this piece separate. CH3 C double bond OH, acetic acid. So same thing will happen here. Same thing will be here. We will have this side H to this O, this C double bond O CH3. This part will be attached again here. Yes? Then here, then here, then here. So how many? 1, 2, 3, 4, 5. So 5 times this is going to attach, so I will take 5 molecules. So 5 here and 4 here and 1 here, 5. So I'll write this thing which I showed you through structure, I write condensed form. What it will be? This group will remain as it is. This CHO will be there, and in place of H this is attached. C double bond O CH3. How many times? This is 4 times. And CH2O किसकी जगह पर आ जाएगा? C double bond O CH3. So we have got 5 times this is attached. So 5 hydrogen atoms are released. 1, 2, 3, 4 and 5. So to the 5 this group, this will be attached. So we will have CH3 C double bond O 5 times. So 5 hydrogen attached. So this is acetic acid. Okay. So this way you will get the compound. What this compound is, see here. If you look for this part, CH3 C double bond O, CH3 C double bond O. Okay, इतना part अगर देखो, तो what is this? Acetate. अगर H हम लगा दें, ये acetic acid. H हटा दें तो acetate. So this is acetate. So how many times acetate we have? 5 times. 4 and 1 5. So pentacetate. तो किसका acetate? Glucose. So this is glucose. This is glucose. Pentacetate. कौन सा ग्लूकोज था? डी ग्लूकोज, और पास में लिखेंगे डी ग्लूकोज pentacetate, and you will have this. So that's all about your carbohydrate. Next biomolecule in the next class, that is your protein.